Account abstraction in Ethereum is becoming very popular. It's largely because users are unable to handle the externally owned accounts due to the complications of private keys, seed phrases, etc. Account abstraction aims to create a smart contract wallet for users such that that becomes the single point of contact for users to interact with as a wallet. The process of generating and safely storing seed phrases remains quite complicated for users, especially with the crash of lot of centralized exchanges. Now, users are planning to move to non-custodial wallets. To improve the existing technology and to be able to onboard the next billion users, developers at the Ethereum Foundation began to propose the concept of Ethereum account abstraction. The core idea or motivation for the account abstraction is basically to reduce the externally owned accounts, or rather, to reduce the existence of two types of accounts, that is, externally owned accounts and contract accounts, to just one account type, that is, contract type. Let's take a look at the specifics of the EIP a little bit to understand better. So EIP 4337 is one of the EIPs, that is Ethereum Improvement Proposals, that talks about account abstraction using alt mempool. This proposal completely focuses on avoiding the consensus layer protocol changes, instead relying on higher layer infrastructure. There is a lot to talk about in this particular EIP because it has evolved over a period of time with several EIPs like EIP 86 or has associated EIPs like EIP 3074, right? Now, the thing that I want you to understand over here is that you can see that to avoid the consensus layer changes, that is to avoid network layer changes, there are no new transaction types for account abstracted transactions. Instead, the existing actions that are basically that already exist are being wrapped up inside a struct called user operation. The smart contracts themselves are capable of performing a lot of operations. However, wallets for users are having specific operations like sending tokens, receiving tokens, being able to store tokens in your wallet, etc. Now let's see what are some of the important things that fall under the user operation struct as described in EIP 4337. The sender is the address, which is the wallet making the operation. So in every smart contract, you will have an owner of the smart contract. However, within the user operation, there's going to be a sender who is the wallet that is making the operation. There is a nonce, which is the anti-replay parameter, which is used as a salt for first-time wallet creation. Init code, which is of type bytes, is the init code of the wallet if the wallet is not yet on-chain and needs to be created. Call data, the data to pass to the sender during the main execution call. Call gas limit, the amount of gas to allocate to the main execution call. Verification gas limit is the amount of gas to allocate for the verification step. And then there are some other parameters. Last but not the least, and an important parameter to focus on, is the signature, which is the data passed into the wallet along with the nonce during the verification step. Now, users send user operation objects to a dedicated user operation mempool. And then there are something called bundlers, which can actually listen in on this user operation mempool and create these bundle transactions. So these bundle transactions then eventually become associated with the wallet operation that the user has to perform. If you go through the EIP 4337, you can understand in much more detail about the entry point contract functionality and so on. However, in our particular lesson, what we are going to focus on is how to deploy a simple wallet as well as how to write a contract that deploys these accounts or wallets for the user. There are lots of other examples as well, which are available in the reference implementation. I want to quickly show you if possible. So you can see that the account abstraction repository is present inside the ETH infinitism. And here you can find a lot of scripts. You can find deployments, deploy, you can find contracts, etc. So there is a bunch of things from the reference implementation, which is what we will be looking at for this particular lesson.